Hello everyone, welcome to the lecture of the advanced course where we will be dealing with the framed wall structures. The example project shown here is a framed wall structure, and in order to see this structure in 3D model, we need to rebuild it. To do this, I select the Build 3D Model command, click on the pencil in the Add documentation, and select the option Wall Framing Visible Only. If I accept this with OK, the program will rebuild the 3D model and we will see the structure of the wall. We can see that the structure is made up of different wall studs, inner studs and other components that we will look at during the presentation. Let's take a look at what these structures look like on the floor plan. Let's look at the partition, as we will create a similar one during the workshop. We see that this partition consists of 3 layers. An outer layer, an inner layer and a core layer. The outer and the inner one is a layer of plasterboard almost 20 mm thick, and the core layer is a terminal insulation. And in between the studs that will be part of the frame structure. We can create a framed wall structure from a pre-created style, or we can create a custom style. We can find the pre-made styles in the building menu, wall tool, and the side menu. If we scroll down, we will find the framed constructions here. Custom style will be created during the presentation. In order to create such a framed wall structure, we will first draw a simple wall, set its layering, and then create the framed wall structure in its properties. Let's get to work. First, let's draw a simple wall next to the floor plan. I'm going to draw a 100 mm single layer wall. I'll place door and window on it. The window should be 1200 mm by 1200 mm. I will adjust the distance from the wall line to 0. Let's open the wall properties and see what settings we need to change to get the framed wall structure. The unconnected height is 3000 mm and the total thickness is currently 100 mm. We will determine the total thickness with the layers, so we are going to set the wall layers first. Currently, we have a single layer wall, so we will add extra layers with the green plus button. We will look through all the properties of the wall layer. The first is the layer number, the second is the function. It is advisable to set the function because that way the program will associate it with the correct layer when a wall meets another wall. So I will define the outer and inner layers as plywood or gypsum. The in-between layer will be the core wall layer. Next to the number, we can find a small arrow that marks this blue arrow which indicates the displayed layer. This indicates which layer is technically the most important for editing. For example, when we simplify the floor plan view, the program will take this layer as the basis, and it will indicate which layer the structure we are currently creating should be placed in. It is advisable to mark the core layer as displayed layer, so I will mark the layer 2 as the displayed layer. The next property is the material, which we will see in the 3D view and in the section 2. The exterior and the interior material will be plaster. And the in-between core layer will be terminal insulation because we are placing insulation between the inner studs, so this is what we will show here. The next property is the thickness. As I said, it is going to be almost 20 mm inside and outside, so I'm writing 18 mm. The core layer is 100 mm. Let's move on to the base offset and the height properties. This allows us to set where the bottom and the top of the wall should be in relation to the support structure. By default, the bottom of the wall will be related to the top of the support structure. If I click on Edit, I can change these with the help of the figure. I can, for example, set the wall to be connected to the top of the floor finish level. The next property is the pattern fill. We can change it by clicking on the Edit button. I can change it to sand hatching for the outer layer as well as the inner layer. For the core layer, I choose the thermal insulation hatching. We don't need to set the size because the program will adjust it to the thickness of the wall layer. I accept with OK, and the modified hatching appears in the figure. We can even set whether the layer should be visible in the 3D or not, or which phase a particular layer should be placed in. I do not modify these. I accept the settings with OK. The layered structure has been formed and the total thickness is 136 mm. The next step will be to create a frame wall structure, which we will also create in the wall properties by clicking on the frame wall structure. We will go through all the menus shown here and discuss their properties. Each of these elements can be switched on and off separately, and each element is labeled with letter as shown in the figure. I'm going to turn on 4 elements: the floor plate, the top plate, and the right and the left wall studs. The elements that I turned on have appeared on the 3D preview. When I click on an element, it is shown in red. We can see that there is a part left empty since we placed the door there. We can set the cross-section and the material of a particular element and copy these to the other ones. This is because it is a complex dialog. We see that it consists of a lot of menu items. Therefore, I don't have to set the properties of each one individually, but here in the copy properties, we can set a default property and we can copy it to the other elements with a few clicks. Let's see how we can modify the cross-section. If we want to use a completely different cross-section than the rectangle, we can click on the plus button to select it. And if we want to modify it, we can do it with the pencil. I'm going to do this now. I'm going to turn off the uniform scaling and set the width to 45 mm and the height to 100 mm. I'm also going to change the material to natural pine. As we can see, the 3D model has not yet changed. This is because we have not yet copied the properties to these elements. For these two properties, the cross-section and the material, I tick the box under Copy and select Copy and Paste the selected properties for all items button. This changes the 3D model. Let's go through the menu items and talk through about them. The first one, floor plate, is going to be the bottom framed element. Otherwise, I can add more floor plate by clicking on the plus button, at which point the program will stack them on top of each other. Now there is no need for an extra element here, so I delete that. We can move on to the top plate. That will be the top framed element. Then the left and the right wall stud will be next. These corner studs will already be visible in 2D view, so we can set the hatching for them. We can also create a custom hatching, but by default the program will mark it with an X. We can also modify the 2D representation by adjusting the line color, the line type, or weights. But for now, I leave those as they are. We can do the same for the right wall stud. We can also add extra elements to these by clicking on the green plus button, or we can turn off the 3D display. Let's go to the next menu item, the inner stud. This is marked with E. The program will now show us in red which element it is. The first column has the same properties as the previously set elements, but here we can select the spacing. We can specify the spacing from center to center or choose clear spacing. D is the distance between the balusters and C is the distance between their axes. I leave it like this for now. We can move on to the header. We can see that this is placed above the openings. This will be important due to fixation. We can create several beams by rewriting the numbers. Let's look at it. Let's rewrite it to 2, for example, and then the program will place them next to each other like that. I can also change the position by clicking on the pencil. For example, I rotate them. They are now lengthwise. As I said, even though we copied the properties, we can still change all the elements individually. Let's move on to the saddle or seal menu. This element is located at the seal line, which will take on the properties of the header. I don't need two elements here, so I'm going to set this back to 1. We can move on to the H-marked jack stud or trimmer. This is the column that runs from the saddle to header, and it is placed on either side of the opening. We can make the same adjustments here. Let's go to the king stud. This will also be placed next to the opening, but this runs the full height from the floor plate to the top plate. Next one is the cripple stud. This will be located below saddle and above the header. We can set the spacing here as well as for the inner stud. Next is the nogging. It supports, for example, the terminal insulation and provides a nogging for the vertical stud. These can be positioned in several ways, alternately, in which case we will be able to specify the relative elevation of the lowest one or at the same height. Now we come to the last menu item, the bracing. This will be located at the edge of the structure, and we are able to set different properties for it. For example, which side it should be on, left or right. I accept the settings with OK and save this framed wall structure as a new style. Let's take a look at the floor plan where we have a framed wall structure created. Let's also look at the 3D model. If we need to dimension and document the frame wall structure, we can do that too. In the floor plan view, I choose the option Accessorize, Place Wall Framing Frontal View from the wall's local menu. I will get the frontal view of the wall, which is otherwise created as a group. This can be scaled, labeled, and later placed on a plan sheet. I mentioned that it is very important which layer is set as layer to be displayed, because the structure will be placed in that layer. Let's see how we can change this. I choose the pencil and set the first layer as display layer in the wall editor. The structure is then placed in the middle of the outer layer. We can also move these structures within the wall. Let's take a look. I go back into the wall properties, and in the Copy Properties menu, I change the offset to 59 mm to place the structure back in the middle of the wall. It is very important to copy this to all the elements. We can see that it is moved back in the middle of the wall structure. I would also like to show you what happens when we place a new window in this wall. I switch to the 3D view, copy this window and place it here. We can see that the program automatically creates the saddle, the header, and all the structural elements that are needed to support such an opening. Let's see how we can manually place a column in this wall afterwards. I go back to the floor plan view and select the building column properties. I will use the same dimensions that I used for the framed structure. The profile will be 45 mm wide and 100 mm high. The height of the column will be 2910 mm and the relative elevation 45 mm, so that it will sit right between the floor and the top plane. I accept with OK and then place the column in the wall, for example here. If I move this wall, we can see that the columns is not automatically inserted into the wall. We need to change this. In the properties of the column in the side menu, I select the Insert Wall option under Constraints, and this will place the column in the wall. If I now change the position of the wall, the column will move with it. The last topic about the frame wall will be connections. I create a wall with the Create Similar command. We can modify the wall connection. I change the L connection to a T1. If I choose the L connection again, the program neatly restores the connections and creates the elements according to the connection type. Let's also look at if I make a partition. Again, I choose Create Similar command and draw a partition. The program creates the corresponding connection. Before we move on to the last topic, which will be designing with architectural grid, let's take another look at the model in 3D. So the next topic is designing with architectural grid. For this, I will start a new project. With the grid, it is very easy to create whole buildings or other buildings with a structure consisting of columns. Let's look at an example. I can create the grid with the drafting grid command. First, I set its properties. We can see the general properties, what kind of layer it will be on, what color, what line type it will be, and we can choose whether to place a rectangular or a radial grid. We can also set the text style. What we will set is the gap between the lines, which will be 3000 mm both horizontally and vertically, and the number of lines, which will be 10 by 10. I accept that and I choose the place command. I place it near the origin. I can modify and move each of its elements separately, and they will be able to interact with the architectural elements. Let's look at an example. I use the building menu, column command, to place a column. This will be a 30 by 30 rectangular column. If I click on the grid and move its endpoint, for example, we will see that the column will follow this modification. I withdraw it and create some more of these columns. I select it and choose Edit Duplicate Matrix. I specify the reference point and set it to be 10 by 10. Then I place it to the right and down. If I click on the grid and move its endpoint, for example, we see that all columns adapt to this change. The elements that will follow this modification are those that are aligned and on the grid. I withdraw this too. I also place beams. In the building menu, I select beam properties. It will be 300 by 100 mm. The relative elevation will be 2650 mm and the material will be concrete. I place it here. And then I copy it with the Edit Duplicate Matrix command. The horizontal element number will be 9 and the vertical will be 10. I place these as well. Here again, I delete few that aren't needed. I move the endpoint again, and we can see that the beams respond to this change as well. These grids can also be extended using drafting grid and, for example, with the straight grid line command. If I draw another line here, it gets a line number and becomes part of the grid. This brings us to the end of the workshop. Thank you very much for joining us for the advanced course, and we hope you found this video series useful. Have a nice day. Bye-bye.